Have you ever wondered how it is that we can produce all the food that we can? How is it that we can support a world population of over 7 billion people? Well, today we're going to look at a process that I believe is crucial in our ability to sustain this many people. The process is the Haber process. It was developed by a German scientist who is actually Jewish named Fritz Haber, and he developed it over the years from 1894 to 1911. As you can see here, the process is designed to combine nitrogen and hydrogen to form ammonia. So today we're going to be looking at the motivation that led up to the development of this process, the mechanism by which this process works, and then lastly, how is this process used today? So what was the motivation? Well, prior to World War I, Germany had been accustomed to import the necessary components for explosives from Chile. So this inflow of components was not compromised during World War I. Germany needed to make the explosives from raw materials found in Germany. Therefore, they needed to develop a process by which they could take the atmospheric nitrogen and hydrogen to make ammonia. So now that we've seen a little bit about the motivation of the process, let's look at how this process works. What were the components that were necessary for the making of explosives? Well, back then the main component of explosives was nitric acid. Nitric acid, for numerous reasons, was derived from ammonia. And ammonia, as we saw before, is made from nitrogen and hydrogen. Both these compounds are very plentiful, but the problem is atmospheric nitrogen has the strong triple bond, which makes it very difficult to break, and therefore it's very difficult to make an efficient process that this reaction can run by. Therefore, certain conditions must be met in order for nitrogen to be fixed or broken and attached to another molecule. Fritz Haber studied the Le Chatelier's principle in order to meet these conditions. Among other things, this principle addresses concerns about concentration and the pressure in a system. First point, if a substance is added to a system, then the equilibrium or balance point in which the system shifts from one side to the other will change so that that substance is consumed in the reaction. Conversely, if a substance is removed from a system, then the equilibrium will shift again and more of that substance will be built. On the other hand, we have pressure. When you increase pressure on a system, the equilibrium will shift so that the number of moles in the system will decrease. Number of moles, that's a number like dozen. This will make the system more space efficient and therefore decrease the pressure as the system strives to reach equilibrium. So how did this apply to the Haber process? Well, Fritz Haber added nitrogen and hydrogen to the system, which caused the equilibrium to shift to form more ammonia. Additionally, he removed ammonia later in the system, which caused equilibrium to shift again to produce more ammonia. Also, the system was conducted under extreme pressure, which caused the equilibrium shift to produce less moles of molecules. So now that we've seen a little bit of how it works and what the reasoning was to develop an efficient process, let's look at some of the uses that are of the process today. The Haber process developed ammonia. And as you know, ammonia is used for anything from floor cleaner to fertilizer. It's very used everywhere. According to the United States Geological Survey publication in 2004, worldwide ammonia production was 109 million tons. Equivalent statement to that would be 60 million Olympic swimming pools filled with ammonia. It's a huge amount. According to the article Feed the World, found at tcetoday.com, the Haber process produces enough ammonia that produces food to feed a third of the Earth's population. Therefore, this could be one of the single most important process that for supporting life on Earth today. In conclusion, we've seen that the motivation for this process was Germany's desire to make explosives from raw materials found in Germany. The mechanism is based on an application of the Le Chatelier's principle. And lastly, it is used extensively and in many different products today. It is ironic to note that the very process that was developed to kill people in World War I is used today to save the lives of millions from starvation. Thank you.